Hello and welcome to graphing quadratic functions. Now what we're going to look at today is when you're trying to make an XY chart and the graph that you're trying to make are the equations in standard form. So we are going to start with the equation y equals 1/2 x squared minus 4x plus 6. Okay, so first thing we want to know is because these quadratic equations can get really big. Let me just label my axes here. So we want to be able to find our line of symmetry. Okay, so how I'm going to find the line of symmetry here is I'm going to use the equation x is equal to the opposite of b over 2a. That'll tell me where to start, and whatever I get for my answer will go here. Okay, and when we're trying to get what we're talking about when we have our a and our b is we're looking for this and this, and let's undo those last two things. I'm looking for the coefficients of that when the equations in standard form that we're going to go in here. Okay, so let's try that again. So if this is ax squared plus bx plus c, then our b must be -4. Now, notice in the equation this is the opposite of b. So if b is negative, like in this case, this is going to be +4. Okay? And this is over 2 times whatever a is. Oh my gosh, a is a fraction. What are we going to do? It's okay, because 2 times 1/2 is just going to be 1. You knew that. So we have our starting point. The line of symmetry is the equation x is equal to 4 over 1 or x is equal to 4. So I'm going to start by plugging that into my equation up here. Okay, so I am going to plug 4 wherever I see x. So it starts off with, and don't forget your order of operations, you have to square first. So I'm going to square 4, then I'm going to multiply 4 by -4, then I'm going to add 6, because that's just plugging in. Remember, this is Plugman's comic, so there's going to be a lot of that plugging in stuff this chapter. Okay, so 4 squared is 16, half of that is 8, 4 times 4 is 16, plus 6, so I have 8 minus 16, that'll give me -8, plus 6 is -2. And I'm going to plot that point. So I'm going to go over 1, 2, 3, 4, and go down -2. Right around there. Oh, there you go. Now, what I know about this ax squared plus bx equals c is because this is a positive a, this is going to open up. So what I found is the minimum of my graph. All right, and that's good to know. So now what I want to do is I want to try numbers that are close to 4. So I'm going to try 5, and to the left of 4 would be 3. Okay, so I'm going to substitute in 5 where x used to be. Alright, so we're going to square 5 because we got a square before we multiply by 1/2. Square 5 would be 25, and half of that, we can make this a decimal. I'm going to make it 12.5. And then 4 times 5 is 20, so we're going to subtract 20, and then we're going to add 6. Okay, just substituting this 5 right here. And 12.5 minus 20 would give me negative 7.5. Then if I'm going to add 6, that's going to give me negative 1.5. Now the good thing about these graphs, okay, so I'm going to go over 1 and up. Yeah, it's not going to move much. I don't know if you guys can see that dot. Yeah, it's just going to be like slightly up, but that's okay. The good thing about this is because we found the line of symmetry. Should be a dotted line here. That's not a very impressive dotted line, but you get the idea. That shows a mirror imagery. So if we plugged in 3, I bet you would get a point at negative 1.5. Now, if you are saying, I don't believe you, Mr. Barnett, then what I would suggest you do is plug in 3 into our equation and figure that out now. Okay, because I'm betting you're going to get negative 1.5 if you did everything right. Okay, we're not going to take the time to do that. We're going to go over 2 more. I'm going to try 6 in the equation and 2. And because there's a line of symmetry, I should get the same answer. Okay? Alright, so now let's plug in 6 into our equation. 6 squared is 36, half of that is 18. 4 times 6 is 24, plus 6. 18 minus 24, well, that would just give me negative 6. Plus a positive 6 is, oh my goodness, a 0. The same thing happens with 6, and that happens to 2. This is going to be over here. Put a point right on the line, and I'm going to put another point over here. There we go. So when I connect these points, what do you know? It's a curve. It's a quadratic equation. Get that parabola shape, and that's good because, again, when you have the quadratic equations, your exponent of 2, it's going to give you that shape. So when we get into solving these quadratic equations, what we're looking for is finding the point where they touch that x-axis. Those are called the roots or the zeros of the equation, and then they're really trying to solve what equation will make this, or what value will make this true. This is a case where there are 2 solutions. Always possible when you have a quadratic equation, because the exponent is 2. Okay, you could have 1 solution or no solution. But what I'd like you to do is go back and try some of the problems I gave you before with the solving quadratic equations. Follow the steps where we find our line of symmetry first, make an XY chart, plug in that value in there, and then plug in values that are close to it. Here's 1 over, and then 2 over. And when you plot these points, you should be looking for your parabola shape. Okay, keeping in mind things like this is a positive A, it's going to open up, not open down, and the smaller this number, the A value is, the wider it will be. The larger that number is, the skinnier it is. So give yourself some practice. We'll look back at Plugman and have a good day. Bye-bye.